Thank you. As you've just heard, I'm a researcher at Mozilla, and my research at Mozilla is broadly about what I would describe as data governance. So I'm interested in where is data coming from, who controls it, who collects it, who makes decisions over it, and so on and so forth. So when this big generative AI hype started around the end of 2022, I was naturally interested in the training data. So I collected information about that. And one name popped up over and over and over again, and you guessed it, that is Common Crawl, a name that I've never heard of before I started that investigation. And I would argue that most people never heard about Common Crawl that do not develop generative AI models. Maybe quick question to this audience here. How many of you have heard about Common Crawl before coming to the session or reading the session's description? Okay. It's actually more than I expected, honestly. So not bad. It is largely unknown to the broader public. And before I really go into the research that I did and my findings, I want to explain some important basics. So what exactly is Common Crawl? Why is it so popular for generative AI? And how are these developers using Common Crawl's data? So first of all, what exactly is Common Crawl? Common Crawl is a massive archive of web crawl data, more than 9.5 petabytes in total. And web crawl data in this case means that Common Crawl mostly consists of the HTML text of billions of websites from all over the internet. And this archive is created and maintained by the Common Crawl Foundation, which is a small Californian nonprofit organization that makes this data available for free on Amazon Web Services. As I've just mentioned, Common Crawl has become one of the most important sources of generative AI training data. Here's some data that I collected. I looked at 47 generative AI models. That is obviously not a comprehensive overview, but it gives you a good impression of the trend that exists overall in generative AI. And as you can see, most of the models have been using Common Crawl's data. There are a few unknowns here, which means that the developers did not disclose enough information about their training data to be sure whether Common Crawl has been used. But I'm very certain that at least some of those unknowns relied on Common Crawl as well. So it is safe to say that most generative AI models published to date have been trained on Common Crawl's data, very often to a significant degree. Significant degree meaning that 30% or more of the overall training data came from Common Crawl. The easy answer as to why Common Crawl is so popular is that you need a lot of data to train generative AI models. And Common Crawl is both massively large and available for free. But to really understand Common Crawl's role in generative AI, we need a bit more nuance here. How are developers using this data and why are they using it? Most developers of generative AI models compose the training data from two different types of sources: targeted sources and web crawl data. Targeted sources are things like Wikipedia, Reddit, GitHub, Project Gutenberg, etc. So well-known websites or platforms on the internet whose data is relatively well-defined, and developers choose this data deliberately because they consider it high quality or it helps to diversify the training data and so on and so forth. So training your model on a composition of these targeted sources is generally good for the performance of this model. However, as I've just said, to create performant models, you not only need data that is high quality and diverse, you also need a lot of it. And therefore, they use large amounts of web crawl data to further scale up the size and diversity of their training data. The contents of this data are not very well defined because it's basically just data taken from websites from all over the internet. It is also impossible to inspect this data manually because it is so large. So you cannot really carefully look at the contents of all the websites that you are including in this data. And this means that the quality of this data varies greatly. You can have articles from high-quality news media next to 4chan-style discussions. However, most developers see those trade-offs as worth it because the performance boost from more training data outweighs those shortcomings, at least from the eyes of most generative AI developers. 1 second. All right, so some leading AI companies like Google, Microsoft, more recently also OpenAI, and a few others have their own crawling infrastructure to collect this data themselves and have it in-house. almost everyone else who is not working in one of these very rich companies takes it from Common Crawl because it is by far the largest freely available source of this data. Now, intuitively, you might think that developers just download Common Crawl and then train the models on it. But that's not true. The reality is more complex because developers neither train their models on unmodified data from Common Crawl's archive, nor do they download the entire archive. Instead, they do the following. First, they take some, but not all of the data in Common Crawl's archive. Common Crawl is not one giant database that you just download somewhere. It is an archive consisting of many, many individual data sets that you have to download separately. And Common Crawl publishes new crawling data every month, and those monthly publications are called Common Crawl dumps or CC dumps. I don't know why they call them dumps anyway. But developers have to start with deciding how many of those dumps they want to include in their training data and how they select them. Some of them will just take the latest dumps available when they start collecting their data and then go back in time. Others select them more or less randomly. But the point is they have to make a selection of those dumps. Then they make an attempt to filter the data that they have extracted from Common Crawl's archive to remove content that is deemed undesirable for model training. As I will explain in more detail in a few minutes, Common Crawl is full of content that you do not want to train your model on. On the one hand, you have like a lot of boilerplate text, like the names of menu items on home pages, but a lot of problematic and especially harmful content as well. And well, finally, after all that's done, they will train their models on this filtered selection of CC dumps. What all of this means is that Common Crawl is a source for AI training data. But it is not an AI training data set itself because developers do not train their models on unmodified data from its archive. And this has important implications for how Common Crawl can and cannot influence generative AI. All right, now we finally come to my research. So for my research, I argued that we should understand Common Crawl as an infrastructure for generative AI data. It is a building block to create generative AI training data. And infrastructures are not neutral mediators. They make certain actions and ways of thinking easier, and thereby they privilege certain ways of doing things. So another way to put it is they invite people that rely on them to act in certain ways. And studying Common Crawl as infrastructure then means understanding what the creators of Common Crawl want others to enable with this data. And I primarily relied on qualitative research to explore this. So I interviewed Common Crawl's director and its main crawl engineer. I analyzed Common Crawl's homepage and posts on its public mailing list. And I gathered public statements by Common Crawl's founder, Jill Elbaz. Now, for the rest of this presentation, I will just give you some high-level takeaways from this research. The first takeaway is that providing AI training data has never been Common Crawl's primary goal. Common Crawl was already founded in 2007, so long before generative AI came up or even before terms like big data became popular. Common Crawl's founder, Jill Elbaz, previously worked at Google, and he got concerned, or he claimed that he got concerned, that Google, his own employer, is becoming too powerful because it had access to all this data that almost no other company had access to at that time. And he wanted to counter this by creating what he called neutral data companies. Companies that provide data to other companies. And he had the money to fund those companies because he had a very high position at Google and was a multi-millionaire when I left Google. So Common Crawl was one of those neutral data companies, a non-profit that was intended to mimic the way Google crawled the web for its search engine and then make that data available to anyone for free in order to level the playing field of technology development so that others have an opportunity to compete better with Google. The second takeaway is that Common Crawl deliberately does not curate its data in any way. It does not want to remove hate speech because it wants researchers that are interested in studying the spread of hate speech on the web to use its data. So harmful content like this is not included in Common Crawl by accident, but more or less by design. I mean, it's not like Common Crawl deliberately collects this data, but if they have it, they don't remove it. Common Crawl's guiding principle here is that less curation of its data enables more innovation and research by the downstream users of this data. So Common Crawl thinks of its data more like a raw material that needs to be refined before it really becomes useful. So what I've just described before about AI builders having to filter Common Crawl before they train their models on it, that is exactly how Common Crawl is intended to be used. Not directly, but after you have cleaned it, refined it, whatever. The third takeaway is that Common Crawl is not a copy of the internet. It is not even a representative sample of the internet. Even though it is massively large, it has a lot of important limitations. And to explain why, we need to go into a little bit into the nitty-gritty of how Common Crawl actually works. So first of all, to stay within the bounds of the US fair use doctrine for copyrighted materials, because it's a US-based nonprofit, and also as a way to balance the size and the quality of its data, there are a few deliberate limitations. In most cases, Common Crawl only grabs the HTML text of websites, so no images or any other media. In some cases they do, but 90% or so is really just text data. Common Crawl also does not collect full copies of web domains. So you will never have a full copy of Wikipedia in Common Crawl, for example. Common Crawl will only take some of its pages, but never all of them. And then finally, these monthly CC dumps are deliberately limited to 3 to 5 billion URLs. That is a lot, but Common Crawl could theoretically collect more, but they don't, to maintain a certain level of quality. To decide what to crawl, Common Crawl calculates each web domain's harmonic centrality. Now, harmonic centrality is basically an alternative to Google's PageRank. It is another method to mathematically determine the importance of a node in a network. And I don't want to go into the math here, but very simply put, the more often a web domain is directly or indirectly linked to, the higher its harmonic centrality. And harmonic centrality essentially captures how accessible a web domain is in the sense that you can basically go to it via links on other pages. Importantly, this harmonic centrality score is not only used to decide if a domain is included in Common Crawl, but also to decide how many pages are taken from that domain. So the higher the score of the domain, the more of its pages are included in Common Crawl. So top domains that have a very high score, like Wikipedia, for example, usually have a lot of their pages included in Common Crawl. But domains that have lower scores are not only less likely to be included in Common Crawl, but even if they are included, less of their pages are in Common Crawl. So to come back to the limitations of all of this, just to name a few. So first of all, the way Common Crawl prioritizes pages to crawl with harmonic centrality makes content related to digitally marginalized communities less likely to be included, because this kind of content is also less often linked to. Then there are a lot of duplicates in these monthly CC dumps. According to the main crawl engineer, about 50% of each dump is made up of URLs that have been fetched at some point in the past. And that's partly because of what I just described. Top domains that score very highly are always included with a lot of pages, while lower scoring ones are maybe not. Then most of the pages in Common Crawl are English. About 50% of each monthly crawl is English, which is partly due to the fact that Common Crawl's technical infrastructure is based in the US, which skews crawls towards English content. And then finally, there's also a growing number of important domains like the New York Times that block Common Crawl because they don't want their data to be used for AI training data. And Common Crawl deliberately allows domains to do that because they want to play nice, basically, with content creators. Which brings me to my fourth and final takeaway. Because of this deliberate lack of curation and the limitations to the crawling process, Common Crawl is still a valuable but also problematic source for AI training data that needs to be used with care, especially when using it to train commercial generative AI products. But the way many developers of generative AI models rely on Common Crawl is problematic. First, there are many dubious claims out there that say that Common Crawl actually is a copy of the entire internet. And so subsequently, training models on Common Crawl's data would allow us to train generative AI on the, quote, entire internet, which just demonstrate a lack of understanding and reflection about the data that Common Crawl provides. In fact, Common Crawl is very upfront about its limitations. And Common Crawl also emphasizes that crawling the entire internet is basically impossible because the internet is constantly evolving. New pages are added and old ones are dying all the time. And as a side note, even if Common Crawl would really be a copy of the internet, we should still keep in mind that there are huge inequalities globally on who is actually online and who is not. About 30% of the world's population is not online at all. Then second, and perhaps more importantly, very few developers really filter Common Crawl themselves. They rely on versions of Common Crawl that were filtered and then published by others. And as a result, there are a handful of filtered Common Crawl versions that are very popular and that are being reused for years. That is not inherently a bad thing, I want to emphasize, because it can help to make generative AI a bit more transparent because you can compare models better when they have been trained on the same kinds of data. But what is problematic here is that the most popular filtered Common Crawl versions to date rely on problematic and very simplistic filtering techniques when it comes to removing harmful content. For example, one of the most popular filtered Common Crawl versions is called C4, which was created by researchers at Google in 2019. And to remove harmful content, the developers relied on a crowdsourced list of keywords considered harmful, the so-called list of dirty, naughty, obscene, and otherwise bad words. You can find that list online on GitHub. You can look it up if you want, but be aware that this is not safe for work stuff because most of the words in that list are related to sex and pornography. So only using that list to filter Common Crawl will remove that content, but will leave a lot of other types of harmful content that is, for example, racist, untouched. Using that list alone also tends to remove non-toxic content from LGBTQ+ communities, for example. So to conclude, I want to emphasize that even though that I have raised a lot of critique here, I want to emphasize that Common Crawl's popularity as a source for generative AI training data also has positive effects. Common Crawl is very transparent and open about its data and its limitations, and that has helped to make the research and development of generative AI more transparent in general. And the fact that it can be used for free allowed researchers and smaller corporate actors to at least somewhat keep up with very rich and resourceful AI companies like Google. And that made the landscape a little bit more competitive. So Common Crawl arguably is achieving here what it was set out to do. It kinda at least leveled the playing field of technology development in this instance. One way forward that would improve the status quo while retaining those positive aspects of Common Crawl's popularity could be the creation of organizations dedicated to filtering Common Crawl in transparent and accountable ways. A big issue in how Common Crawl is used to date is that these most popular filtered Common Crawl versions were all created by the developers of generative AI models. So filtering Common Crawl for them was just a stepping stone towards their actual goal, which was to create these models. And that limits the amount of time and energy that they can dedicate to the filtering of Common Crawl. So having organizations dedicated to this task that continuously work on improving the data sets that they have derived from Common Crawl could be a big step forward. Long term, however, I would argue that less reliance on data whose contents are difficult to pin down would be most desirable. To some extent, this might already be possible as smaller generative AI models get more powerful, but it will require technical advancements to allow developers to train their models on less amounts of data. But it will also require an ecosystem of smaller and more curated data sets to reach a certain scale and to incentivize developers to use that kind of data rather than these broad chunks of web crawl data. All right, with that, I thank you for your attention. You can scan this QR code to check the full report if you like, and looking forward to your questions.